So good day class. So today we're going to start our lecture on Building Tech 3, which is about steel and concrete design. Although I can say for certain that we have already covered some topics already regarding concrete during our Building Tech 2, and then we attempted to make a complete set of plans. But we were not able to, what you call this, compile them. In our Building Tech 3, I would require you to make a complete set of plans, or for now at least copy them so that you'll have an idea. Okay? Then you're going to see what really are in the construction drawings and documents. Then I want you to perfect it. Okay? So I think one semester is not enough to train you guys for that. Okay? Remember guys that these details, these construction documents, they will be your bread and butter someday when you're practicing as architects. Okay, so I'm going to discuss to you guys some contents which are already in our use step. Okay, I think because this was already prepared by the cluster, and I think it's okay. So, okay, I think it's stated here the class policies. I think you're already well aware of that. But in my class, in Building Tech 3, I will accept late submissions class, but there will be of course deductions. Okay, so those who submitted in time will have higher grades compared to those who were late. So it's just as simple as that. Okay, so I think it's already here, the layout. So generally, it is ideal for you guys to have to draw this in a tracing paper. But just in case you can't afford, since this is the pandemic, then a lot of us are experiencing financial problems. It's really affecting our economy also. So I'd like you to make um, your own logos. Then try to copy the USTP logo also. Then right here, the student name. Then submitted to. So instead of architect Gerald Harayo, you're going to write my name here. Then write the title of the drawing. Okay, so if you can find, if there's no tracing, if tracing paper is too expensive, you can use Cartolina. Yeah, there's Cartolina as long as it is not too dark, as long as I can see the drawings, because I'll be requiring you to make a compilation of everything that you will be doing here from the beginning to end so that you'll have a copy of your work as a student. Okay, now for our first requirements class, I think most of you are familiar already with what's in the perspective, what's in the site development plan, ground floor, second floor, front side elevation, left side elevation, and right side elevation. Okay? So you'll be copying these drawings in new step. Also the ground floor plan. Okay? So you've noticed that written here in the notes is that all exterior and perimeter walls should be 6 inches or 150 CHB. That's a standard. And all interior walls are 4 inches CHB. Okay? So you'll be submitting to me these drawings a month from now, up to the, okay, so I'll end it with the schedule of doors and windows, because that's something that we have not covered in Building Tech 2 intensively. Okay? So when you draft, guys, these drawings, I want you to follow the alphabet of lines. I want you to know which area should be light, which area should be dark. So I'll be judging, grading you based on how neat and how well you presented your works. Okay? Then, of course, class, every week we're going to have lectures, especially in steel design and steel structures. Then I'm going to just want you to learn from the resource videos and comment on them. But your requirements from the perspective, site development plan, ground floor plan, second floor plan, front side elevation, left side elevation, right side elevation, up to the rear elevation, cross section, longitudinal section, reflected ceiling plan, second floor reflected ceiling plan, schedule floor finishes, schedule floors and windows, schedule of doors. I want you to submit this to me on, so today is March. So I'll give you until March 10 to complete them. Or okay, let's do it at March 12. Okay, so those who submit um, later than March 12, they are all late. Okay, so I want you to take note of your responsibilities for this section, for this class. Okay, so I'm a bit confident because you already submitted it before. Then there are a lot of those who really performed well in the class. Then if you have problems, class, especially with the paper type, I won't mind as long as you use the same sizes. Then it would really be better, class, if you begin to practice now using the correct paper size, even if you're not going to use the correct paper, so that you'll have a feel on what you're going to do and what you will really be doing as future architects. Okay, so because remember, class, this skill will be your bread and butter someday. So I'm really concerned for you to learn this. I'm really concerned. So especially now that this is a pandemic, then I really feel that this thing should be taught um, on a face-to-face basis. But since there's nothing we can do, the world is in chaos. Please adapt. Then just do your best. Then if you have any problems, reach out to me. Okay? And today, we're going to have a brief lecture on structural steel construction. So this won't take long. Okay, let me adjust it. Okay. So let's start with the most common structural steel sheets. So you have the square bars, then you have the round bars, the plate bars, the angle bars, the channels, the I-beams, the T-beams, the H-columns, the Y-flanges, and the Zs. In most common class, you're going to encounter if you're just working on residential projects are the square, round bars, plate bars, angle bars, and channels. Then, when you're working in bigger projects already, let's say commercial building, uh, 3 to 4 stories or more, mid-rise to high-rise, that's the time you're going to see I-beams, T-beams, H-columns, wide flanges, and Zs. These types of steel shapes, will be taught to you in detail when you reach your steel design, when you're going to compute uh, the different loadings. And it's the different loadings, the effect of the people inside, the effect of the wind, the effect of earthquakes on your buildings. So in our building tech 3, I'm just going to introduce you to this one. So these are different shapes. Okay. So structural steel girders, beams, and columns are used to construct a skeleton frame for structures ranging in size from one story to skyscrapers. The structural steel is difficult to work with on site. It is normally cut, shaped, and drilled in a fabrication shop according to design specifications. This can result in relatively fast, precise construction of a structural frame. Structural steel may be left exposed in an unprotected, non-combustible construction, but because steel can lose strength rapidly in a fire, fire-rated assemblies or coatings are required to qualify as fire-resistant construction. Okay? If you remember, class, the unfortunate event in 9/11 when the United States of America was attacked, then the Twin Towers fell down. So it's made of structural steel. Okay, but you can see the towers collapsing because when the planes exploded, of course, it's carrying a lot of fuel. Then this fuel generate really high temperatures. So at really high temperatures, steel could will really melt. Okay? That is why when you use steel, though it's fast, I think it's better if you're going to have it encased in a concrete. Then you have a one-way beam system. Each pair of external columns supports a long-spanning beam or girders. This form of construction is suitable for long, narrow buildings, especially when a column-free space is desired. The absence of columns in the interior is an advantage in structures as car parks, as freedom from obstruction makes for greater and safer maneuverability, besides allowing the layout of the parking spaces to be altered at any time. So have you noticed, class, there's a parking building near USTP. So it's the back of Shakey's and it's connected with um, the hotel, Lux Hotel. So I think it's made of steel. It would really be nice if you can see that it's a pandemic. So there's nothing you can do about it. Then you have a two-way beam system. So a two-way beam system is a two-layer system where beams frame into girders increases floor depth considerably and provides more space for mechanical systems. Steel girders span the short axis of a building bay, thus contributing to the lateral stability of the structure. Then you have a three-way beam system. Okay, so you look at the beams. So it's used when a large column free space is required, where spanning long plate girders or trusses can be used to carry the primary beam, which in turn supports a layer of secondary beams. So as you can see, class, the span is really high. So we're going to use a three-way beam system. Then you have steel columns. So we share different steel columns and connections. So steel columns are of the following types. So you have A, the struts of one or two angles. These are used for compression members in roof trusses, light towers, and lattice girders. So the two angles of a double strut are riveted together by rivets driven through washers placed between the two angles at intervals of 4 to 6 feet. So this is the example, class. Struts of one or two angles. Then you have starred angles. So of two or four connected by a batten plate spaced at intervals of 3 feet to 4 feet. So these are used to support the light loads. So this is the example. So try to familiarize yourselves with the different steel column types. And of course, you have the lattice columns. It's made of channels or angles connected by lattice bars, which are often used when light loads to be supported on long columns. So when you see long columns, um, it's really high. In this high at as ang height. Okay? So like this one. So this is the lattice. Then you also the roll each column. So these are obtainable with depths ranging from 6 inches to 16 inches and are now commonly used instead of built-up columns and in steel skeleton construction. Then you have built-up columns. So these are usually each sheet section formed by a combination of plates and angles, although box columns with two or more webs are not uncommonly used in heavy building frames. Then you have top chord sections of heavy trusses are usually unsymmetrical and are made of two rolled or built up channel sections in a cover plate. So the open bottom side of the section is latticed. Then you have columns for bends are sometimes made up of a pair of channels in an I-beam with batten plates at intervals of 3 to 4 feet. Connecting the flanges of the channels, columns made of four angles in a web plate are commonly used in mill building bends. So this is the example. Then you have batten columns. So are those in which two component parts of the column are connected only by batten plates. So they are decidedly inferior to lattice columns and should be avoided if a continuous plate or latticing can be used instead. So these are the battens. Okay, so we're going to end our lecture now for now at batten columns. So we're going to continue this next week. So don't forget about the drafting that we're going to do, class. It's posted in NewStep. Then I'll post it again in our group page in Facebook. So if you have any questions or clarifications, don't hesitate to contact me through my email or through my Facebook Messenger. So I hope that you're all doing fine. So stay safe. Then try to learn as much as you can this pandemic season because that's the only way you can raise your skills, especially that the architecture and construction industry is really an environment where skills are really given primary importance. Okay, so see you next meeting.